Good morning. I say good morning because it's 5:20. Been up for about a half an hour getting ready. It's a Saturday morning at 5:20. Who doesn't get up at 5 o'clock in the morning? Someone the other day left me a little memo that said, please stop drinking coffee. Are you worried about me? Are you upset that I enjoy a good cup of Dunkin' Donuts in the morning? Holy mackerel, that's hot. Maybe I should stop drinking coffee. Holy crap, that's hot. Ooh, my eyes are itchy this morning. I haven't woken up yet. But I'm ready for some probability. Unit 9. We're getting close, kids. We only got 2 units left. By the way, all of this stuff, if you haven't heard before, can be found at our website at www.nkinfinity, I can't even spell my own name this morning, .com. Now, Miss Marta Gil Paramos, one of our foreign exchange students this year, Marta Gil Paramos from España, was complaining about my handwriting the other day, along with a couple other students. So I'm going to try to be neater today. There's a reason everything that's in my classroom gets typed, because my handwriting is terrible. Plus, I'm looking at you while I'm writing down here. So that's not very good. It's not going to happen. All right, over this unit, we're going to talk about probability. I'm hoping that most of the stuff in this video, which is just day 0, is stuff that you already, through your 9, 10, 11 years of education, have already come across. Hold on just a second. I'm looking for something. We're going to define all of this stuff soon. What is probability? Well, let me just tell you in layman's terms what probability is. And then as we get going in this unit, we're going to talk about all the really difficult stuff about probability. So this unit's going to start out not bad, but then it's going to get kind of tricky and kind of tricky fast. So you really want to be paying attention. You do not want to get behind in this unit. So make sure if you don't understand what's going on, you come see myself, Miss Newman, Miss Acker, whoever your math teacher is. You come see them and you start figuring out what's going on, okay? How about we just say this is likeliness somehow that doesn't, I'm trying to write neat and spell at the same time. Oh my gosh, it's gonna be an impossible task. The likeliness of an event happening. How about that? That's really layman's term. We're gonna get official definition in a couple days. The likeliness of an event happening. Maybe I should stay in bed on a Saturday morning. The likeliness of an event happening. I'm not really a fan of this definition. It's okay, but it's the probability. It's the probability of some event. So let's say we say the probability of some event is, in layman's terms, again, the number of successes. And I probably should say number of successes over the total number of possibilities. You know why I don't like writing neat? It just takes longer. It's going to be a rough one, kids. It's going to mean me some Dunkin' Donuts coffee, but I got to remember it's hot. I only like hot coffee, so this cup's okay, but I got to get one that keeps it warmer for longer for them really long videos that are coming. I'm so excited. All right. What is the probability of choosing a king out of a standard deck of cards? So, we probably need to talk about cards in general. Let's see if I can find a nice space off to the side here. I think I need to talk about deck of cards because I think you should be comfortable with a deck of cards. The problem with it is you all are too busy on Snapchat, Instagram, Snapajam, Lebedam, Facebook, whatever else you're on. You're too busy doing that and not playing a deck of cards. I don't know how many parents and families don't play cards anymore. It's crazy. There are 4 suits. They're called suits. They are hearts, diamonds, clubs, and spades. Now this is also good for my Marta Gilparamo, and I have a foreign exchange student this year, NYS Algebra. Of course, I sort of butchering their names, I'm sure, who probably don't have our sort of deck of cards, the same deck of cards that we use, or maybe not use the same names. Two are red. Let me say, these two are red. These two, oops, this is going to be really thick. These two are black. There are 52 cards in a deck. Therefore, that means half red, half black. 26 red, 26 black. Now, if there's 52 cards in a deck, and I divide that by 4, that means there's 13 cards in every suit. Oh, I'm starting to get sloppy again. I don't know if I was ever neat, though. Let's see. There's 4 of each card, 4 of each number. I hate to say number. Like, they start at 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we get crazy. Jack, king, queen. Why did I go queen? I forgot the queen, because the queen's most important, right? Jack, queen, and king, and ace. Generally, the ace is considered highest. The 2 is considered lowest. You got to be careful. Sometimes they read that. These are called face cards because they got faces on them. There are 12 face cards. Now, why are there 12? 3 in every suit. And there's 4 suits. Hence 12 cards, right? All right. So we've gone through the basics. I don't think I missed anything. But if I did, I'll come back. So what is the probability of choosing a king? Well, there are 4 kings. There's 4 of every kind. 4 kings out of 52. Now, if you don't like that, could you reduce it to 1 out of 13? You certainly may. You certainly may. What is the probability of rolling a 3 on a fair die? I should really say a fair 6-sided die, because there's lots of die that have more than 6 sides. So what is the probability of rolling a 3 on a fair 6-sided die? Well, that would be 1 out of 6. What is the probability of choosing a diamond in a standard deck of cards? Well, you could do one of 2 things. There are 13 diamonds out of 52 cards, and oftentimes you're going to want to use that one, especially when we get into OR situations. We'll talk about those. But you could just say 1/4. Either one of these answers, because they are in fact equivalent, would be okay. What is the probability of choosing a vowel out of the alphabet? Now, okay, guys, vowels are A, E, I, O, and U. I know that when you're young, they say, and sometimes Y. Y is not a vowel most of the time. 99.99999% of the time, unless you got the word by. And I guess then you can call it a vowel. But we're going to say these are our only vowels. Or my, or shy. Do you get it? So there are 5 vowels, and there are, in fact, I know this comes as a surprise to some of you, 26 letters in the alphabet. And again, for Marta Gilparamo and NYS Algebra, who knows, they might have more letters in their alphabet. I know in Germany they've got an S-set, and they got all these weird little funky letters that you got to use. So sometimes you got more than 26 letters in the American alphabet. We probably should have said that. All right, that's so far so good. Okay, kids, let's make a deal. If you roll a 1, and let me tell you what the most important word in this thing is. If you roll a 1 or a 6, you can have what's behind door number 1. Very important word. If you roll a die so that the first number is a 1 and the second number is a 6, you've written behind door number 2. Which door is more likely? Let's see. The probability of rolling a 1 is 1 out of 6. Should have said a fair die again, kids. What's the probability of rolling a 6? 1 out of 6. They have equally likely on a fair 6-sided die. The probability of an OR. Now, what you need to remember is if you have an OR means we're going to add. If you have an AND, it's probably right behind my head. If you have an AND, we are going to multiply. All right, so the probability of a 1 or a 6, 1 out of 6. Remember I said we're going to add, and we're going to cover this in depth. All right? 1 out of 6 or 1 out of 6. Well, that would be a what? 2 out of 6 or a 1 out of 3 chance. That's like a 33% chance right there. That's not bad, right? And another way to think about it is if a 1 or a 6 comes up, I'm good. That's 2 out of the total 6. Okay, what about this way? I can win door number 2 if I get a 1 and then a 6. Now, it's important that I said first a 1 and then a 6, because if I just said a 1 and a 6, I could get a 6 then a 1 or a 1 then a 6. So either way, so you got to be careful the way I word it. So the probability of getting a 1 is 1 out of 6. The probability of getting a 6 is 1 out of 6. And if we have an AND situation, you have to multiply. Now notice, in multiplying, you multiply the numerators and you multiply the denominators. Oh, we're going to get good at some fraction stuff. Ooh, fractions, love them. So 1 out of 36. 1 out of 3. I think door number 1 is a lot easier to win. Which door is more likely to win and why? Number 1. And simply because the probability is greater. I'll save myself some writing. Let's talk about the next page. Ooh, we got some presents for you. If you pull a king or an ace from a standard deck of cards, you win. All right, so let's see. This is why you want to use 52. Probability of a king is 4 out of 52. The probability of an ace is 4 out of 52. The probability of a king or an ace. All right, here's where it's going to get a little bit crazy. Probability of a king or an ace is 4 out of 52. Remember, in this case, I'm only pulling one card. One card is pulled. Plus, probability of an ace is a 4 out of 52. And that would be an 8 out of 52. Now, if I reduce, that's 4 out of 26, 2 out of 13, whatever, so on and so forth. This one's a little bit trickier. If you pull 2 cards from a deck, such that the first card is a king, this is important right here. You do not replace it. And the second card is an ace. I know you've done this before. I know you've done this in 9th grade, so you should have known this. So the probability of a king the first time is 4 out of 52. But now I've got a king in my hand. We got an AND situation. I've got to multiply. I've got a king in my hand. What's the probability of getting an ace now? Well, there's still 4 aces left in the deck, but there's only 51 cards left in the deck. So in this case, my probability is 16 out of, remember, we multiply the numerators, multiply the denominators, and I always forget this number, 20, is that right? She's got 2652 written down. I think that might be right. Multiply 52 times 51. Oops, that's wrong. Oh, yeah. Just go into calculator. 52 times 51. 2652. Yeah, okay. It's one of those numbers I should have memorized by now. So, just a reminder that replacing or replacement, or when you see the word replacement, changes the probability. Which present has a higher probability? Clearly, gift 1 has a higher probability. Overlapping events. So we're going to be talking about overlapping events as well, in depth, very in depth. So let's talk about this. What is the probability you pull a club or a number less than a 4? Remember I said aces are generally considered high, but oftentimes they'll tell you about it. What is the probability you pull a 4, a club, or a number less than 4? So a club would be all the clubs here. And over here, so in this event, we'd have all the clubs. And in this event, we'd have all of the numbers less than 4. So let's see about this. Let's think about this. This is really going to be, well, let's figure out what the probability of a club is. That should be pretty easy. The probability of a club would be 13 out of 52. Again, if you want to use, especially with OR situations, you want to use 52 because it makes the adding easier. You know, if I said 1/4 there and I tried to add that to something else, I'd need a common denominator, and that thing makes things a little bit trickier. But remember, we're going to add here, so we're going to add what's the probability of getting a number less than 4? So that would be, so this would be 13 out of 52. That's pretty straightforward. A probability of a number less than 4. So all the numbers that are less than 4 are 2s and 3s. So that means there's 4 2s and 4 3s. So that's 8 out of 52. So we'll add that in. 8 out of 52. But as you can imagine, or maybe you can't, we've duplicated some numbers. We have a few repeaters in there. We have a few numbers that have repeated themselves in there. For example, the 2 of clubs and the 3 of clubs. The 2 of clubs is in there. The 3 of clubs is in there. The 2 of clubs is in there. The 2 of clubs is repeated in there. And the 3 of clubs is repeated in there. So we've duplicated these 2 cards. They've been added. Those 2 cards were added here, and those 2 cards were added here. So we got to get rid of those 2 cards by subtracting 2 out of 52. And that's what's called an overlapping event. Something that can happen in the description of both events. So in the middle here would be the overlapping part, the 2 of clubs and the 3 of clubs. Over here will be all the other clubs, the 4, 5, 6, 7, 8, 9, 10, Jack, King, I always forget Queen, and the Ace. So notice, and over here with numbers less than 4, that would be the 2 of hearts, the 3 of hearts, the 2 of spades, and the 3 of spades, and the 2 of, what have I forgot, diamonds, and the 3 of diamonds. So let's see, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, just counting them once. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Let's see what happens here. 13 plus 8 is 21, minus 2 is 19 out of 52. So be careful with overlapping events that can happen in more than one possibility. And in that case, we always subtract the overlap. What I would like you to do, and I'm going to go over these so we can avoid some time in class. I'm going to go over these questions. There's only 8 of them. But I would like you to pause the video right now. I'm going to pause it and take a little coffee. But I want you to try these on your own. Try to translate them to an and or an or. Try them on your own, and then come back, and then we'll see if you got how many of these you got right. So this will give you like a nice primer and a prepper for class that you're going to start hopefully in the next day or 2. All right? So pause the video and then come back and watch. No. I will not stop drinking coffee. Whoever said that. Okay. What is the probability of rolling doubles on a pair of fair dice, 6-sided dice? Well, this is actually starting out with a very difficult question. This is actually a really difficult question. It's actually really easy, but it's very difficult. Does it matter what you get on the first die? You just got to match it on the second die. So I'm going to show you two different ways to do this problem. On the first die, you're going to get one. You're going to get something. You're going to get a 6 out of 6. You're going to get some number, whatever it is. On the second die, you have to match it. So on the second die, you remember, in order to get doubles, you got to get something and match it. Well, in order to match whatever you got here, and it doesn't matter what you got here, so any 6 will do. But on the second one, you have to match it. That is a 1 out of 6. And in that case, it is a 6 out of 36 or a 1 out of 6. Now, another way to think about that is I can get 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6 and 6. Well, to get 1, 1, that's 1 out of 6 times 1 out of 6, which is 1 out of 36. To get 2, 2, that's 1 out of 36. To get 3, 3, that's 1 out of 36. So forth and so on. If I add all those up, since there's 6 of them, that's 6 different ways of getting doubles out of 36 different possibilities. What is the probability that you draw one card from a standard deck so that it is a heart or a face card? All right, so it's an or situation, so we're going to add. So the probability of a heart is 13 out of 52. We're going to add the fact that we got a face card. There are 12 face cards out of 52. However, we have overlapped a few. What was overlapped? We have, I have to make a correction on this answer key. Actually, on the last page as well. All right, we have overlapped a couple things. What have we overlapped? Well, we have overlapped a few face cards. For example, in this, what do we do? A draw a card from heart. In these hearts, there was a Jack of Hearts, a Queen of Hearts, and a King of Hearts. So there were 3 cards that were overlapped. These 3 face cards were overlapped, so I got to get rid of those. So I got by subtracting off 3 out of 52. That's a 52. And so let's see, 25. So that gives me 22 out of 52. Wow. Out of 200 students in the senior class, 12 students are both varsity athletes on the honor roll and on the honor roll. There are 74 seniors who are varsity athletes, 51 seniors who are on the honor roll. What is the probability that random selected senior is either on the varsity or on the honor roll? All right, so let's talk about this. We've got 74 senior athletes. We've got 51 seniors on the honor roll. We got 74 seniors that are athletes. We got 51 seniors that are on honor roll. And we have 12 students who are both athletes and on honor roll. So what is the probability that a randomly selected senior and they're either on a varsity athlete? Well, the first thing is there are 74 out of 200 students that are athletes. If we add to that the fact that there are 51 seniors that are on honor roll. So right now that gives me all of the athletes and all the honor roll students, but there are 12 students that are in the overlap situation. that are in both groups. So if you were lining them up, you'd have the athletes here, you'd have the honor roll students here, and then there would be 12 students that were counted in this group and were counted in this group. So we've got to eliminate the one counting of them. We don't eliminate two countings of them. We only eliminate one counting of them. So 12 out of those 200 were counted twice. So let's see, 74 plus 51, that's 125, minus 12 is 113 over 200. CeeLo is playing blackjack against a computer and he gets dealt an ace. What is the probability that the next card is a king, queen, or jack, or 10? Let's assume it's just one standard deck of cards. And I know when they play blackjack, I think they run 3 or 4 standard deck of cards, but we're going to do one. So, we don't care about the fact that the ace is already there. We want to figure out what is the probability of a king, a queen, a jack, or an ace. Well, only one of those cards is going to be pulled, but there are 4 kings, but there's only 51 cards left. Or there are 4 queens, 51 cards left. Or there are 4 jacks, 51 cards left. Or there are 4 aces, or 4 tens. So, that would be 4 tens. I just wrote 4 tens. How about 4 out of 51? Now, the reason there's only 51 is the ace was pulled. I already pulled an ace. So the ace was pulled. These are all considered 10s. The ace is considered 11, which makes 21, which is called blackjack. So there are 16 out of 51. Remember, when you add, you only add the numerators, keep the denominator. So there's a 16 out of 51 chance that the next card will be one of these 3 that will give them blackjack. What is the probability of selecting 5 cards out of a standard deck such that you have a royal flush? Ace, king, queen, jack, 10 in all the same suit. This is a difficult one. This is another difficult one. So maybe you got this wrong, but you got part of it right. A royal flush. So what is the probability of getting an ace? Okay, that's 1 out of 52. Oh, I like the way she did this. So let's say the ace is going to be the dictator of which we do. And that there's 4 aces out of 52 cards. Right? So you have a 4 out of 52 card chance of getting one of those aces. After that, you have to match it. So let's say you pulled the ace of diamonds. All of these have to be diamonds. Or you pulled the ace of clubs. All of these have to be clubs. So there's 4 possibilities for aces. But after that, there's only 1 possibility for a king, 1 out of 51. Then you have a 1 out of 50 chance for a queen. Then you have a 1 out of 49 chance for a jack. And then you have a 1 out of 48 chance for a 10. 1, 2, 3, 4, 5. So that would be 4 out of, I don't even know. I don't have it written down here. All right, where the heck's my calculator? There it is. All right, so 52 times 51 times 50, 50 times 49 times 48. 311,875,000, 311,875,200. Well, 4 divided by, so you have, it's going to give me that. I would like the exact answer. Nope. Whatever. You don't have much of a possibility. This doesn't happen very often, kids. What's the probability of rolling a pair of 2s or a pair of 3s on on a pair of fair dice, 6-sided dice? Pair of 2s or a pair of 3s on a 6-sided dice? Well, I can get a 1 out of 6 times a 1 out of 6. That would give me a pair of 2s. Or, so that's an adding. This is an and an or. 1 out of 6 times 1 out of 6. This will give me my pair of 3s. So this is 1 out of 36 plus 1 out of 36. So that would be 2 out of 36. All right. Raphael is really lucky. During a magic trick, 4 successive draws from a standard deck of cards. He did not replace the cards. He drew 4 jacks. Find the probability of doing this. 4 jacks. That's a 4 out of 52 times and 3 out of 51 times 2 out of 50 times 1 out of 49. Well, the numerator is easy. It's just 24. But the denominator is not so much. 52 times 51 times 50 times 49. 6,497,000. 6,490,000. I'm trying to be neat, kids. 6,497,400. Do you understand why nobody wins at casinos? Crandall, the card shark, selects a card from a standard deck of cards. What is the probability he randomly selects a 7 or a black card? Well, the probability of getting a 7 is 4 out of 52. It's an or situation, so we're going to add a black card. Now, I could do 1/2 here, but that would be really bad because I'm trying to add, and you'll see why in a minute. So I'm going to do 26 out of 52. However, 2 of these 7s were black, so I counted them twice. So I got to get rid of those 2 out of 52 cards. Notice, if I leave everything in terms of 52, I already have a common denominator, and I don't have to worry about that. So that would be 30 out of 52 minus 2 out of 52, which would be 28 out of 52. All right, kids. That's your primer, that's your prepper, that's a little bit of a head start on the unit of probability. I hope you enjoyed. Goodbye, kids.